Greetings, how are you today? We are starting section 4 of chapter 7, which actually means we are going over the halfway point. So halfway through means we're going to have another little quiz. So after this lesson, I'll be posting a review and a quiz, and we'll continue on from there. It's the first week of May. It's been pretty nice outside. It's going to get a little colder, but, we'll be all right. So let's get started. Our goal today is to solve logarithmic equations and logarithmic inequalities. However, I'm going to give you a little warning at first. Okay. I'm going to tell you something that we're going to consider. First of all, we are always going to use positive bases. Now, is there such a thing as a log to a negative base? There's some usefulness in different applications. It causes a lot of trouble, and it's so something we're going to avoid by strictly saying that we're only going to use positive bases. The study of logs with negative bases is beyond Algebra 2. And I want to show you what that assumption is going to lead us to. So if I rewrote this, wouldn't this mean that x equals 2 to the third? Which in this case then x equals 8. So since this number out here is technically an exponent, and I'm taking the exponent to this base, or using the base in this exponent, my answer for x is always going to be positive. All right, here's what I mean by that. I'm going to just take any number. Let's take the number 4. Now, if I raise 4 to the second power, it becomes 16. Or what if I use a negative exponent? Oh, it's 1 over 16. Okay, what if I use a fractional exponent? Well, that just means square root. That's 2. All right, what if I use a fractional exponent that's negative? Well, square root of 4 is still 2, and the negative puts it on the bottom. All right, there is no power, even 0. If I raise it to the 0 power, it becomes 1. There is no power that I could have that yields me a negative answer. Okay, that's important. There's no power that will yield a negative answer if my base is positive. Which means this number here cannot be anything that's 0 or that's negative. Now we're going to be solving equations, so that's going to become very, 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 very important, because we're going to get some answers that's going to make that a possibility. Well, it's not a possibility, so I have to exclude those answers. So I just want you to remember that when we get to those problems, I'm going to say things like, oh, but remember, we can't take the log of a negative number, and it will be an impossible answer. So let's start with this. X plus 5 equals the log base 4 of 256. Now all I want you to do is to rewrite this the same way you've been writing them. Okay? So this 4 is your base. This x plus 5 would be your exponent, and it would equal 256. And now we solve that the way we've been solving these problems. We can change it to the same base. I'm going to pick 2. We might be able to use a base 4, but I'm going to use a base 2, because I know that this is 2 to the 8th power. Again, it's just we've been using these. Remember 2 to the 6th was 64? So if we do another 2, we get 128. Another 2 is 256. So I chose a base 2. So now the bases are the same, so I can set these equal to each other. So we've done these before. There's no difference. The only difference is we're starting with a log. We convert the log into an exponent, and then we solve. So we get 2x plus 10 equals 8. Subtract 10 from both sides and divide by 2. Now, My answer's negative, but that's okay because I'm not taking the log of the negative number. If I put negative 1 in place of x, negative 1 plus 5 is 4. So this is saying that 4 to the 4th equals 256, which is correct. All right, same way, let's rewrite it. My base is 2. My exponent is 3x minus 5 and 1024. All right, my base is 2. Can't break that down anymore. And maybe you recognize 1024. It's 2 to the 10th power. Anybody out there with computer applications knows that 2 to the 10th power 1024 is a common number that we use. Either way, it doesn't matter because we're just going to solve the exponents because the bases are the same. So I'm going to add 5 to both sides and then divide by 3. So x equals 5. 3 times 5 is 15. 15 minus 5 is 10. Means 2 to the 10th power is 1024. It's correct. All right. Base is 3. Exponent is 5. And it equals that. Now, besides 3 to the 5th power, it's a pretty straightforward equation. What is 3 to the 5th power? Let's see. I'm just going to use my calculator and figure that one out. It's 243. I could have figured that out on my own. Sorry. All right, solve the equation. I add 17 to both sides. Gives me 260. Divide by 4. 260 divided by 4. Let's see, it's 130. 65, I believe. Let me just double check. You didn't realize you're just sometimes not confident in your math that day. Well, today's that day. Well, I mean, every day is that day. Who am I kidding? All right, now, what's going on here? Well, we have two things going on. We got logs on both sides, but I'll tell you what. If the logs are the same, all we have to do is just set these expressions equal to each other. Not a problem. We just solve that like normal. We add x to both sides. We subtract 6. So if negative 3 equals 3x, just divide both sides by 3. We get that. So x equals negative 1. Now, is it okay for x to equal negative 1? Well, let's plug it back here and find out. So if I put negative 1 in place of x, I get 3 minus negative 1, or 4. 4 is okay. And just to double check, this should also be 4. 2 times a negative 1 is negative 2. 6 plus negative 2 is 4. All right, they're good. All right, we got something else going on. We got squares, and we got this thing, but the good news is these logs are the same. So we just set these expressions equal to each other. Now, if you're solving a quadratic, you've got to set it equal to 0. Then we factor. Let's see what two numbers would we use in this case. Looks like a 4 minus 4 and a plus 1. Because negative 4 times plus 1 is negative 4, and negative 4 plus 1 is negative 3. So that looks good. Our two answers are these. Now we do have to make sure they both work. So let's try 4. So I'm going to put it into x squared minus 4. All right, so I put in 4. So what's 4 squared minus 4? 4 squared is 16. 16 minus 4 is 12. Looks okay. Put it into the other term, 3x. Well, 3 times 4 is 12. So they're positive and they're equal, so that's a good number. So I know x equals 4 is one of my answers. Now we have to check negative 1. So negative 1 squared is 1. Oh, I get negative 3. That's not good, because I can't take the log of -3. It won't work. I'm sorry, over here, log of -3, it won't work. For that same reason we talked about in the beginning of the video, you can never get an exponent that gives you an answer that's negative or 0. So I know this doesn't work. So I could check the other one too, but it would be a little bit redundant, but you might as well since we're here. If I try 3x, all right, what's 3 times -1? -3. See, they still equal each other, but they may equal each other, but they're negative, and you cannot take the log of a negative number. So our answer in this case is just going to be 4. It's the only answer that works. All right. So just be careful of checking the answers just to make sure they work. All right, we've got another one here. The good news is the bases are the same, which means we just set these equal to each other. Again, it's a quadratic equation, so we've got to bring everything to one side and set it equal to 0. All right, let's factor this. Be 5, because 3 times 5 is 15. This looks like it'll work. Well, no, it doesn't. Now it does. -5 plus 3 is -2. -5 times 3 is -15. So our two answers that we get are 5 and -3. Now, let's check. If x equals 5, and we're testing x squared minus 15, what's 5 squared minus 15? 5 squared is 25. 25 minus 15 is 10. Looks good. If I try 2x, well, x is 5. 2 times 5 is 10. So that's good. They're both counts and they're positive. Let's try -3. Oops. Let's try -3. Okay. I can already tell it's not going to work because I just looked up here and said 2x. Well, if I let it equal 2x, what's 2 times -3 is -6. Not going to be good. I can try the other one if I want, although I really don't need to. It's redundant now. -3 squared is 9. 9 minus 15 is -6. So yes, they equal each other, great, but they're negatives, so it's no good. Our answer then, in this case, is only, we'll put it up here, it's only 5, because -3 does not work. Okay, that's enough for this video. I will catch you with the next video where we're going to be doing inequalities. So have a good one. Bye.